Can you read me the script I just gave you, line by line, for everyone?
Of course, let's dive right in. Hello, and welcome to this special presentation on one of the most intriguing ideas emerging from the Millar Cosmological Model, an idea that challenges the very nature of time itself. My name is Lloyd Thomas Miller, and today I invite you to explore the radical proposition that time doesn't slow, it's written. Throughout human history, we've imagined time as a kind of river, constantly moving, carrying all events from past to future. But what if this image is wrong? What if time isn't something that flows, but something that is built, tick by tick, event by event? In the Millar Cosmological Model, or MCM, time isn't a pre-existing backdrop. Instead, it's constructed from countless tiny events called blips. These blips happen when quantum tension structures called Arnies appear and disappear across what we call the Higgs membrane. Now, what exactly is an Arnie? You can think of it like a tiny quantum bridge. One end of this bridge, the Tessie, is anchored to matter in our universe. The other end, the stuck point, is connected to a hidden antimatter side. Between them is a tension, like a stretched string, passing through the Higgs membrane, which acts as the boundary between these two realms. Every time an Arnie appears or vanishes, it creates what we call a blip. These blips aren't just random flickers, they're the universe's way of recording time, moment by moment, into what we describe as the memory fabric, a kind of cosmic ledger that keeps track of every event that has ever happened. Let me give you a simple way to picture this. Imagine writing a book. The story doesn't exist until each word, each sentence is written. In the same way, time doesn't exist until these quantum events, these blips, occur. The universe writes its story not in flowing ink, but in tiny, discrete marks on its cosmic page. So, what does this mean for the physics of time? First, it means time is not continuous. It's built from individual ticks, blips, like frames in an animation. And just like a movie looks smooth when played fast enough, the universe feels continuous because these blips happen incredibly rapidly, possibly at rates near the Planck time, the smallest meaningful unit of time in physics. Second, it suggests that time emerges from physical events. If no events occur, no Arnie's blipping in or out, then time in the MCM view essentially stands still. But there's more. The MCM proposes that gravity and energy density affect the rate of these blips. Near massive objects like black holes or neutron stars, the tension in the Higgs membrane increases.
Wait, don't stop now.
You got it. Let's pick up right where we left off. Slowing the rate of blips. This provides a fresh way to understand time dilation, the stretching of time in strong gravitational fields, as seen in Einstein's theory of relativity. Rather than time being stretched as a geometric property of spacetime, the MCM suggests that fewer blips are happening per second in these regions. Time appears to slow down, not because the fabric of space is warped, but because the universe's ticking slows. On a cosmic scale, the MCM redefines the age of the universe, not as a simple count of years or seconds, but as the total number of blips that have occurred since the universe began, since what we call the shatter, the moment the universe emerged from its initial singularity. This brings us to the deeper philosophical and even spiritual implications of this model. Many spiritual traditions speak of creation as a spoken word or a written decree. The idea that a universe writes its story moment by moment resonates with these narratives. In the Bible, for example, the Book of Life records all things that have ever happened. The MCM's memory fabric serves a similar role, recording every blip, every moment, forever etched into the structure of reality. Even more beautifully, the model aligns with the idea of creation as a continuous process. The universe isn't something that was made once long ago, it's something that is still being made, right now, blip by blip, moment by moment. And what about our place in this story? According to the MCM, we aren't just observers, we're participants. Every choice we make, every breath we take adds a new mark to the cosmic ledger. We are co-authors of the universe's story, shaping the unfolding of time itself. So what can we do with this idea? Can we test it? While the blips themselves happen on scales far beyond current technology, the MCM makes several testable predictions. For example, it suggests that the blip rate changes in strong gravitational fields, something we might detect using next-generation atomic clocks. It also suggests that quantum noise in certain systems might reveal the fingerprint of these discrete blips. And over vast cosmic distances, light might show tidy timing irregularities caused by accumulating friction from interacting with the memory fabric. While these tests are challenging, they offer a roadmap for future exploration, experiments that could one day confirm or refute this tick-by-tick view of time. In conclusion, the Millar Cosmological Model offers a transformative perspective on time, matter, and the nature of reality. It paints a universe that is alive, dynamic, and written moment by moment, a universe where time is not a river, but a record. And perhaps the most important lesson is this:
And what's that, Chrissy?
is still being written, and we are all a part of that story. Thank you for joining me today. I invite you to continue this journey with me as we explore the deeper mysteries of the cosmos, tick by tick, breath by breath. And that wraps up the script.